All right, folks. So we're in the home stretch here. What I'm doing here is recording a quick video to summarize activity 3 of the acid-base balance simulation that we did in class. And this deals with renal responses to respiratory acidosis and respiratory alkalosis. So lots of big words there. Let's break it down. Renal refers to the kidneys. So the kidneys are the main organ in the urinary system, and they are going to do a lot of things for us. They filter body fluids, they control water content, and importantly for this, they control the concentration of certain ions within the body. And those can include things like sodium and potassium that are important for nerve conduction, and it can also include things that would alter the pH of blood and body fluids. So that's obviously what we're concerned about here. You'll remember that acidosis, respiratory acidosis, is a lower than normal pH below 7.35 caused by an excess of carbon dioxide. People with chronic lung issues, people with asthma can often deal with respiratory acidosis. Respiratory alkalosis, on the other hand, can happen as a result of hyperventilation if that hyperventilation occurs as part of a panic attack. So, luckily for us, the kidneys do a really good job of compensating for what the lungs are unable to do. So my parents both had chronic lung issues. Their lungs sucked at being lungs, and therefore their kidneys needed to compensate for that. So there are two ions that we're concerned about here. The first here, where I'm pointing, is H+, hydrogen. And hydrogen is the ion that makes acids acids. So the pH scale is based on the concentration of hydrogen ions in a solution. The more hydrogen we have, the lower the pH and the more acidic something is. So if we would want to lower the pH of something, we would want the kidneys to retain hydrogen ions in the bloodstream rather than excreting them in the urine. Because if we get rid of them in the urine, we don't have them in the bloodstream anymore. On the other side, we have the bicarbonate ion, HCO3, right here. Now, baking soda is an example of a compound that has the HCO3, the bicarbonate ion, in it. And baking soda is a base. We know it reacts with vinegar to form water in a neutralization reaction. So the more bicarbonate ion we have, the more basic something will be and the higher the pH will be. So if we wanted to raise the pH, if we were in a state of acidosis, for example, we would want to retain bicarbonate ions and not excrete them, not get rid of them in the urine. So I'm going to go ahead and jump into this activity. This one is probably the trickiest. I think it's a bit overwhelming, but that's why it bears repeating. So first, we're going to see, and we're going to kind of confirm that under normal circumstances, we're going to, so we've set the amount of carbon dioxide to the normal levels, right, in that average value. And the pH is also within normal levels. So we're going to run this through, and what we're looking at here is a simulated kidney. The main part of the kidney that does the filtration is called the glomerulus. That's meant to be represented by this little ball right here. And we're running the blood through. The blood is being filtered, and certain substances are coming out in the urine, which we see developing here. So, as we might expect, the levels of hydrogen and bicarbonate, the ions that make things acidic, that's hydrogen, and basic, respectively, bicarbonate, are normal. Normal pH, normal concentrations of all these ions in the urine. So, we're going to go ahead and refill this. And now I'm going to go ahead and reduce the amount of carbon dioxide. So when I reduce the amount of carbon dioxide, we're lowering the PCO2. So this is question 1 here. We're going to look at what happens to the concentration of these ions in the urine. Now you notice that immediately the pH went up. So now we're in a state of respiratory alkalosis, which might occur when you hyperventilate. And so we want to see how the kidneys are going to compensate for that. So we're going to run this through. We see that it's in the glomerulus. Filtration is starting to happen. We're starting to produce some urine here. And in a moment, we're going to see what the levels of these two ions are all about. So as we finish this, we notice that the levels of hydrogen are decreased. That means that instead of peeing them out, instead of excreting them in the urine, we've actually retained these in the bloodstream. And that makes sense because hydrogen lowers the pH. The more hydrogen we have, the lower the pH will be. And that is the goal here. If the pH is too high, then we want to do something to bring the pH back down. And the thing that the kidneys can do is decrease the amount of hydrogen that it pees out by retaining that ion in the bloodstream. Now, as we might have also predicted, we're getting rid of bicarbonate because retaining bicarbonate would raise the pH even further. So the levels of bicarbonate ion are elevated in this case in the urine. So we're getting rid of most of the bicarbonate that's left over. So that is what happens in response to respiratory alkalosis, a higher than normal pH. So we're going to go ahead and refill this, and then we're going to reset. So now we've added more carbon dioxide. We've raised the pCO2, the amount of CO2 in the blood, to about 1.5 times its normal level. And sure enough, the pH in the blood has gone into acidosis, respiratory acidosis. So this is probably what my parents' urine would have looked like in the context of their lungs being generally terrible at being lungs. So we're going to go ahead and start this. It does take a minute, as you've seen. And what we might predict here is that we're going to do something to bring the pH back up to normal levels. That's the hope, at least. If our kidneys are working properly, they do a really good job of compensating for the lungs. So as we finish here, we notice that the levels of hydrogen in the urine are elevated. So this is the stuff we're not keeping. This is the stuff we're getting rid of. And the reason that hydrogen is elevated is because we don't want it in the bloodstream anymore because it would further lower the pH. We don't want that. What we do want is to raise the pH. And the ion here that is a base that will raise the pH is bicarbonate, HCO3. And we notice that the amount that is being excreted in the urine has decreased because we're retaining it in the bloodstream. And the more of this bicarbonate we have in the bloodstream, the higher the pH is going to go. So if we retain enough of that bicarbonate, the idea is that the pH will go back up to about 7.4 and will be safe. So I hope that this was a good summary of activity 3 in our acid-base balance simulation, and have a great day.